Dear Chairman and colleagues, my name is Apostu Izabela-Maria and I will present you the paper entitled Monitoring the Water Quality of Jiu River in Dolj County, elaborated in collaboration with my colleagues representing University of Petroșani from Romania and National University of Water and Environmental Engineering from Ukraine. The presentation includes a brief introduction, the description of the studied area, the material and methods used, the results and discussion section, and conclusions. The central objectives of the European Water Framework Directive is to achieve a good status or a good ecological potential for all bodies of water, both surface and underground. Based on the principles contained in this directive at the level of the Craiova Water Basin Administration, a management plan is under development, a plan that has to solve the main problems related to water management, providing solutions to ensure the current and future water needs of the population and the economy. Jiu hydrographic basin is located in the southwestern part of the Romania, being one of 11 water administration basins existing at the national level. Jiu River has a length of 339 kilometers, a total of 52 tributaries, and it flows into the Danube River. A wide variety of relief forms are distributed on the Jiu Basin surface, from mountains to hills and plateaus. We identified the most important and significant point sources of pollution: urban, industrial, and agricultural pollution sources such as wastewater, electric power plants, pneumophysiology hospitals, social medical facility, food industry, chemical industry, petroleum industry, penitentiary, and others. In terms of releases of pollutants into surface water resources, Table 1 and 2 show the monitored average quantities of organic substances expressed as chemical oxygen consumption and biochemical oxygen consumption, and nutrients such as total nitrogen and total phosphorus per categories of agglomerations and pollution sources, while the Table 3 shows the quantities of heavy metals measured and monitored. The main categories of diffuse sources of pollution are represented by localities that do not have wastewater collection systems, adequate systems for collecting and removing sludge from sewage treatment plants, or compliant household waste dumps, agriculture and agrozootechnical farms identified as potentially vulnerable to pollution by nitrates, pesticide units that do not comply with the legislation in force, and other agricultural activities. Industrial warehouses of raw materials, finished products, auxiliary products, non-compliant waste storage, units producing diffuse accidental pollution, and abandoned industrial sites. The three control sections were established. First point, downstream of Filiaș city. Second point, downstream of Craiova city. Third point, 50 kilometers upstream of the confluence with the Danube River. Water samples were collected monthly in 2019, according to the standard in force, from the most important points in which untreated wastewaters are discharged into the Jiu River on the territory of Dolj County. The surface water classification is based on the results of water quality monitoring and provides for a surface water classification, a system divided in 5 quality classes. From the ecological point of view, based on the alteration of physical, chemical, and biological values, the 5 qualities are the following. Class 1, very good ecological status. Class 2, very good ecological status. Class 3, moderate ecological status. Class 4, poor ecological status. And Class 5, very poor ecological status. The collected water samples were analyzed in the authorized laboratory of the Romanian Water Administration, Craiova. According to the analysis results that can be found in the extended paper, several conclusions can be drawn. Some parameters such as dissolved oxygen, biochemical oxygen consumption, chemical oxygen consumption, nitrates, phosphate, total phosphorus, total nitrate concentration suffer a negative change, suggesting that discharges of wastewater generated by industrial, agricultural, and household activities occur between the sampling sections. Jiu River falls from first or second to second, respectively third class of quality from point 1 to point 3. However, the quality of Jiu River does not suffer a significant worsening, falling into the third category in all three control sections. From the point of view of fecal coliforms, Jiu River falls into the second category of quality, having a good ecological status, and for the rest of the analyzed parameters, Jiu River falls into the first quality class. Another way of assessing the quality of Jiu River water for the three control sections is based on the calculation of the water quality index, which is defined to compare water quality from different water sources and to monitor water quality variations over time by aggregating individual indicators expressed in physical units into a single water quality index on a conventional scale from 0 to 100. For each sample, a table is produced with all the results for the water quality parameters, and then, using the scale of the quality, we determine the quality of the water according to the calculated score. This method involves the interpolation of the results of the water quality parameters, analyzing with a series of predefined curves shown in the literature to obtain the value of Q indicators, after which to the Qi values will be assigned a given weight Wi. The two tables present the necessary data and the calculation of the water quality index for the three control sections considered on the Jiu River in order to characterize its quality in Dolj County. Using the three values calculated for the water quality index, the chart was constructed so we can observe how the Jiu River water quality evolves on the investigated section. The slightly fall from P1 to P3 classifies the water of the Jiu River in the third quality class according to this method. In conclusion, both methods used to determine the quality of the Jiu River in Dolj County led to the same result, namely medium quality water. The results highlight the necessity to implement urgent measures to bring the Jiu River to a higher quality level in line with the European objectives in the field to ensure at least a good ecological potential. In order to achieve this goal, we recommend connection of households to modern and efficient sewage and treatment systems, ensuring efficient systems for evacuation of rainwater and wastewater, apply less polluting technologies and water efficient technological processes, save water through recycling and reduce the water losses, extract useful substances from wastewater and sediments, and reduce discharge of priority substances and priority hazardous substances. Thank you for your attention.